Good morning. Today we are dealing with the session C Programming, Introduction to C Programming, Basics of C Programming. First of all, as we know, C is one of the popular language, general purpose and procedural programming language. First of all, what is actually a programming? Program is a set of instructions given to a computer. A programming language refers to means of communication used by a human to instruct a computer to perform a specific task. Computer only understands binary codes, zeros and ones. Coming towards C, C is one of the structured and general purpose programming language, as I mentioned. C was developed by Dennis Ritchie in 1972 at Bell Laboratories. Overcomes the problems of B and BCPL languages. It inherits the features of B and BCPL languages. Moving towards features of C programming. First of all, C is a robust language. C is strong and powerful language because of its varieties of data types and powerful operators. C is portable. That means program written for one computer can be run on another. That's why C is portable. Next, C is structured programming. Every C programming can be divided into functional modules or blocks, functional blocks or modules. That makes C programming easier. Next, another feature of C is building functions. There are several standard functions that are available in C library. Okay. Next, C has the ability to extend itself. As I mentioned, C has a standard library. We can add our own functions to C library. Okay. Next, moving towards structure of a C program. Structure of a C program consists of documentation section. First documentation section, then link section, definition section, global declaration section, main function section and subprogram section. Documentation section deals with the command lines, giving the command lines. That means the author of the C program, name of the C program and other details. There are single line commands and multi-line commands. Next, link section. Link section actually tells the compiler to link the functions from C library. Here the preprocessor directives #include stdio.h, conio.h are given. stdio.h, standard input-output header file. Okay. Next, definition section. Definition section actually defines the symbolic constants. For example, pi, #define pi 3.14 is an example for symbolic constant which is given in the definition section. Next, global declaration section. Global declaration section actually defines the global declarations. We can define the variables here. We can define the global functions. We can declare the global functions here. Outside of a function, we can declare the global variables. Next, the main function section. Main function section consists of executable statements and the declaration part and the execution part. Declaration parts consist of declaring the variables. After the global declaration section, there is main function section. Here it consists of two parts, the declaration part and the execution part. The declaration part tells declaring the variables. Next, the execution part. The main function, the C program executes from its main function section. Next to the subprogram section, here actually the user-defined functions are involved. All the user-defined functions are mentioned here. Next, coming towards C tokens. The basic building blocks are the C tokens. Simply, C tokens are the smallest building block or smallest unit of a C program. Words from the character set are the building block of C. In C program, each word and punctuation is referred to as a token. The smallest individual unit in a C program is called as a token. These tokens represents the individual entity of a language. The C tokens can be classified into keywords, identifiers, constants, strings, special symbols, operators. First of all, keywords. Keywords are nothing but system-defined identifiers. Keywords are the reserved words of the language. They have specific meaning in the language and cannot be used by a programmer as a variable or a constant name. Okay. C is a case-sensitive language. It considers both the uppercase and lowercase treated as different in a different manner. That's why C is a case-sensitive language. There are 32 keywords in C programming. Okay, keywords are nothing but it is a system-defined identifiers. Some of the keywords are given, for example, auto, brake, car, constant, continue, etc. are some of the given examples of keywords. Next, character set. What is a character set? C language consists of some character set, numbers and some special symbols. For example, the alphabets from A to Z, the digits from 0 to 9. Special symbols includes braces, left parenthesis, right parenthesis, square brackets, all this, white spaces, etc. That means C character is nothing but the character of C consists of alphabets of English language, consists of digits, special symbols and white spaces. Moving towards identifiers, another C token, identifiers. Identifiers allows us to name data and other objects in the C program. Each identified objects in the computer is stored at unique address. Identifiers is nothing but it is the name, it is the data name and other objects in a program. There are user-defined names. These are user-defined names. Identifiers consist of sequence of letters, digits, but there are some rules for identifiers, such as first character must be an alphabet or an underscore. First character must be alphabetic character. First character must be an alphabetic character or underscore. It must consist of alphabets, digits, underscore. Okay. First 63 characters of identifiers are significant. It cannot duplicate with the keyword. As I mentioned, C is a case-sensitive language. That means the uppercase letters and the lowercase letters are treated in a different manner. There are some valid examples for identifiers and also given some invalid identifiers. Moving towards constants. Constants are the data values that cannot be changed during the execution of a program. Like variables, constants have a type. Constants are nothing but they are the data values that cannot be changed during the execution of a program. Constants can be classified into numeric constant, character constant. Again, numeric constant classified into integer constants and real constants. Character constants again classified into string character constant and single character constant. Integer constant. Integer constant or the integer literal can be decimal, octal or hexadecimal constant. A prefix specifies the base or radix 0x or capital letter 0x for the hexadecimal, 0 for octal and nothing for decimal. Some of the examples are given below. Next, real constants. Continuously varying quantities are represented by numbers containing fractional part, just like 17.54. Okay. Real constants are nothing but these are continuously varying constants, continuously varying quantities that can be represented by numbers. These are the real constants are continuously varying quantities are represented by numbers containing fractional part. For example, 17.54. You can represent floating point literals either in decimal form or in exponential form. Here are some examples given. Next, single character constant. Single character constant enclosed within a pair of single quote marks. For example, Here X is given. X is a single character which is given in single quote mark. Next, string constant. String literals or constants. String constants are the sequence of characters enclosed within double quotes. A string is a sequence of character enclosed within double quotes. A string contains characters such as letters, numbers, special characters and blank space. For example, hello. Hello is a sequence of character given in double quotes. Next, C supports backslash character constants or escape sequences. C support backslash character constants. For example, /n refers to new line and /t refers to tab. Here are some examples given. Next, moving towards variables. A variable is nothing but it's a data name that may be used to store a value, store a data value. A variable is a data name that may be used to store a data value. A variable may take different values at different time during execution. A variable is nothing but it's a named memory location that have a type such as integer or character, etc. The type determines the values that a variable may contain and the operation that may be used with its values. For example, num1, a, roll number are examples. Some of the examples are given. There are certain rules for declaring or naming a variable. There are certain rules for naming a variable. A variable name can have letters, both uppercase and lowercase letters, digits and underscore. But a variable name start with a letters and underscore. The first letter of the variable should be either a letter or an underscore. Uppercase and lowercase are significant. But variable, that means I mentioned you that C is a case sensitive language. That means it treated the uppercase and lowercase in a different manner. So, while giving a variable name, uppercase and lowercase are significant. Variable name should not be a keyword. That means duplication with this keyword is not allowed in C variables. White space is not allowed. Okay, these are the basic rules. These are the rules for naming a naming a variable. Given some examples of declaring a variable. Char is the data type here and code is the variable name. Okay, int is the data type and I is the variable name. Long is the data type and national debt is the variable name. Okay, these are some examples of declaring the variable and naming the variable. Also given a program to add three numbers. Here we declare int a, int b, int c and int sum. 4 variables we are declaring here. Given here we can see that there is a local declaration. Within the main function we can declare the variables locally. And outside the function we can declare as a global. Here we are declaring the variable as local variables or local declarations. Just add the 3 variables here. Given the 3 numbers from the user, and by using scanf function we read the 3 numbers. We read the 3 numbers from the user and just add these numbers, and we get and we return the result. Next, data types. A data type specifies the type of data that a variable can store. Data type is nothing but it's a type of data the variable can hold, such as integers, floating point, characters, etc. A type defines a set of values and a set of operations that can be applied on those values. Data types in C. Data types in C can be classified into basic or primary data types, user-defined data types, derived data types, empty or void data type. First of all, basic data type. Basic data type includes integers, floating points, characters. User-defined data types includes structures, union, function. Derived data types includes arrays, pointers. And empty, I mentioned that it's a void data type which does not return any value. These are the classification. Basic data type again or primary data type again classified into integers, floating points, characters. Integers again classified into signed and both both signed and unsigned forms. Floating point, float, double and long double. Character, char, single character and unsigned character. Sorry, signed character and unsigned character. These are some of the examples of data types. Examples of data types, basic data types. For character data type, the size of the bytes is 1. This is for 32-bit CPU. Next for short, the size of byte is 2. Moving towards integer data type. Integer data type in C is used to store the whole numbers without decimal values. Okay, the range is given and the size of integer data type is 2 bytes or 4 bytes. And the format specifier used for integer data type is %d. Next, character data type. Character data type allows its variable and store only a single character. The store size of a character is 1 byte. It is one of the most basic or primary data type in C. The range is given and the size of character data type is 1 byte. The format specifier used for character data type is %C. Next, floating point type. In C programming, floating point data type is used to store floating point values. Float in C is used to store decimal and exponential values. Range is given, the size is 4 bytes and the format specifier for floating point type is %f. Next, double type. The double data type in C is used to store decimal numbers with the floating point values with double precision. Okay, the size is 8 bytes. Next, void data type. As I mentioned, it does not return any value. That means void. The void data type in C is used to specify no value is present. It does not provide a result value or it does not return any value. This is an example program. Here, in A is a variable and its data type is int. B is a variable and its data type is float. CH is a variable and its data type is char. C is a variable and its data type is double. Okay, and the values are assigned with an assignment operator. Next, operators. Operators are the symbols that are used to represent a mathematical calculation or logical comparison. Operators are the symbols that are used to represent a mathematical calculation or logical comparison. Based on the functionality, C operators can be categorized into 8 types: arithmetic operators, relational operators, logical operators, assignment operators, increment or decrement operators, conditional operators, bitwise operators, and special operators. Arithmetic operators means, as we know that arithmetic operations, addition, subtraction, multiplication and division. But in case of programming, arithmetic operation, these are the operators used to perform the basic operations I mentioned, such as addition, subtraction, multiplication, division, etc. Addition operation is used to add 2 operands. Symbol plus symbol is given. For example, 52 plus 8 is given. Next, subtraction symbol to subtract 2 operands. There is an example, 12 minus 2. Multiplication to multiply 2 operands. Division to divide the operands. That means to divide the left hand operator by the right hand operator symbol. For example, 10 by 2. The division operator returns the quotient. For modulus operator, it returns the remainder. For example, 5 by 2. While performing modulo operation, 5 mod 2, the result is, remainder is 1. Next, operators. Next operator is relational operator. These operators are used to compare the values. So, it is also known as comparison operator. These are the operators used to compare the values. So, it is also known as comparison operator. The result of these operators is always a Boolean value, either true or false. Some of the relational operators are given: equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to. Equal to. Equal to refers to check whether two operators are equal. 10 equal to 20. It will return false. Right. Next, not equal to. Not equal to, it will check the two operands are not equal. 10 not equal to 20. It will return true. Greater than, to check whether first operand is greater than the second operand. 20 greater than 87. It will return false. Next, less than. Less than, to check whether first operand is less than the second operand. For example, 10 less than 20. It will return true. Less than or equal to, greater than or equal to check greater than or equal to check whether first operand is greater than or equal to the second operand. 10 greater than or equal to 20. It will return false. Less than or equal to check whether the first operand is less than or equal to the second. For example, 30 less than or equal to 67. Yes, it will return true. Next operator is bitwise operator. These are the operators perform bit level operations. Perform bit level operations on operands. Okay. X is equal to 10, y is equal to 12. Corresponding binary values are given for x and y. There are bitwise AND operator, bitwise OR operator, bitwise XOR, left shift and right shift. Bitwise AND performs AND operation between the operands x and y. Bitwise OR performs OR operation between x and y. Left shift is used to shift of bits towards left. Right shift is used to shift the bits towards right. Next, assignment operator. This operator used to assign. Assign, from the name itself, we can give the definition. This operator is used to assign a value or an expression to a variable name. Okay. For syntax is given. Variable name is equal to value. Okay. Here the variable name A is given and the value is 10. That means 10, the value 10 is assigned to the variable A. Next is logical operator. These are the operators used to check two or more conditions. Logical operators are nothing but used to check two or more conditions. The result is always a Boolean value. That means it will return either true or false. Logical AND performs logical AND operation. Logical OR, it will perform logical OR operations. And the logical NOT, it will perform the logical NOT operation. Moving towards another operator, conditional operator. This operator is used to construct a conditional expression. Is of the form expression 1 question mark expression 2 colon expression 3 and putting a semicolon. This operator, conditional operator, is used to construct a conditional expression. Okay, which is of the form that I mentioned. Expression 1 question mark expression 2 colon expression 3 and semicolon. Here expression 1 is evaluated first. If the expression 1 is true, then the expression 2 is evaluated. Okay, if the expression 1 is true, then expression 2 is evaluated and will return the value. If the expression 1 is false, then expression 3 will be evaluated and return. That means if the expression 1 is false, the expression 3 is evaluated and returned. Here expression 2 never be considered in case if expression 1 is false. For example, given the result is the variable name, result equal to the assignment operator. Mark greater than or equal to 40, question mark, pass, colon, fail. This is the expression given. Here the result is, I mentioned, the result is the variable name and the assignment operator is given. Here if the mark is 87, then it will pass and return the result, pass, and otherwise it will return fail. Only if the result is returned if the mark is greater than or equal to 40. Then only it will return the pass. Otherwise, it will return fail. Next operator is increment operator. Increment and decrement operator is a unary operator. The increment operator plus adds 1 to the operand. Okay. It can be of two forms, pre-increment and post-increment. Pre-increment means adding 1 to the operand and then use it. Okay. Pre-increment. In case of post-increment, operand plus. Principle here is use and change. First of all, use the operand. Next operator is increment operator or decrement operator. Increment operator or decrement operator is a unary operator. The increment operator plus adds 1 to the operand. It can be of two forms, pre-increment and post-increment. Pre-increment means plus operand. That means adding 1 to the operand and then use it. Post-increment means operand plus. Post-increment means operand plus. That means use it and then change, adding 1 to the operand. Likewise, decrement operator is also a unary operator. I mentioned decrement operator minus. Subtract 1 from the operand. For example, a minus. Here we using a and then subtract 1 from the operand. In case of post decrement, operand minus. That means we are using the operand and then decrement or subtract 1 from the operand. Okay. Next, another operator is special. Supports special operators such as comma operator or size of operator. Comma operator. The comma operator mainly used to separate variables in a program, and also it is used in the iterating statements. Next, special operators. Support special operators such as comma operator and next one is size of operator. Comma operator. The comma operator is mainly used to separate variables in a program, and also it is used in iteration statements. For declaring 3 variables, for example, here, without comma operator we can declare int a semicolon, int b semicolon, int c semicolon, and with comma operator we can declare int a comma b comma c semicolon. That is the use of comma operator. Next, another operator is size of operator. Support another special operator, that is size of operator. This operator is used to find the desired size of a given variable. Syntax. For example, int a equal to 10. Here a is the variable name and int is the type, and 10 the value is assigned to a. Here the size of operator, the syntax of size of operator, size of a, it will return the value 10. Next, expression. What is an expression in C? An expression is a combination of variables, constants and operators. In mathematical case also, it's a combination of operands and operators. Expression is nothing but an expression is a combination of variables, constants and operators. C can handle any complex mathematical expression. For example, a plus b star c, a plus b star c plus d, etc. like that. Moving towards precedence of operators. When an expression has 2 or more operators, the system need to identify the correct order or the correct sequence of the operators. Operator precedence. The precedence of operators is nothing but it specifies the order of or the particular sequence of the evaluation of operators in the expression. For example, to high to low precedence, there is some precedence order from high precedence to low precedence. First of all, left parenthesis, right parenthesis, left square bracket, right square bracket, first priority. Next priority, multiplication, division, modulo operation, and Next priority, addition and subtraction. Next is associativity. We can see that many operators are having the same precedence. In that case, we use associativity to evaluate the expression. Associativity is nothing but the direction in which we evaluate the operators if they have same precedence. There are two types of associativity: left to right associativity, left to right and right to left. Left to right means the operator of same precedence is executed from left side to right side. Right to left side means the operator of same precedence is executed from right side to left side. For example, here given the expression 2 plus 5 minus 3. In case of left to right, from left to right, first of all we add 2 plus 5, that is 7. Then subtract 3 from 7, then that is 7 minus 3, which is equal to 4. It is L to R, that means left to right, add 2 plus 5 is equal to 7 first, and then 7 minus 3 is equal to 4. In case of right to left associativity, subtract. First we subtract 5 minus 3, that is 2. Then we add 2, that is 4. And the result is same. We can see the same result, but in the first expression, we just evaluate the expression from left to right, and in the second case, we just evaluate the expression from right to left. But the result comes same. Next is operator classification. Based on the number of operands, the operator can be classified into unary operator, binary operator, ternary operator on the basis of number of operands. From the name itself, unary means single, only single operand is there. Unary operators are the operators with only one operand. As I mentioned, increment operator, decrement operator is a unary operator. For example, assign 30 to the variable x is equal to 30. Minus x means it's a decrement operator. It's a pre-decrement operator. And the value and the result is 29. Okay. Next, binary operator. Binary operator are the operator with two operands. From the name itself, we can give the definition. Binary operator are the operator with two operands. They are used to basic calculations and comparison, arithmetic relation, etc. For example, A is 10 and B is 90. A equal to 10, B equal to 90. A plus B equal to 100. Just add the two numbers. This is an example for binary operator. Next is ternary operator. Ternary, from the name itself, we can identify. We can identify the number of operators. Ternary operator are the operator with three operands. They are used to basic condition checking and conditional operator, etc. Basic condition checking, such as condition operator, etc. For example, result equal to mark greater than or equal to 40, question mark P colon F. That means here result is the variable name and equal to is the assignment operator. Mark greater than or equal to 40, question mark P colon F is the expression. If mark greater than or equal to 40, then return P or pass. Otherwise, it will return F or fail. Moving towards another topic, mathematical function. As I mentioned from the beginning, there are several functions that are available in C library. There are several built-in functions that are available in C library. C has a vast library, and C has the ability to extend. That means we can create our own functions and add to C library. Here the mathematical function, these are the built-in function. That means system defined function, not the user defined function. These are the system defined functions. C supports some built-in functions to find the square root, power, sine, cos values, etc. and also to add the functionalities of this function in the program, we use the appropriate header file. We use the header file math.h for mathematical functions. Okay. Here the header file used is math.h. Basic functions, such as some of the basic functions, some of the basic mathematical functions are given. Square root of n to find square root of a number. Power of x comma y to find the power of variable. For example, power of 2 comma 3 gives 2 to the power 3. 2 to the power 3 gives 8. Okay. Sine of x means sine value of x. Cos of x means cos value of x. Some of the examples are given. There are a lot of built-in functions that are available in C library. Moving towards input-output function in C. Reading or writing character in runtime, C has certain input-output functions. C has certain I/O functions, input-output functions that can be used for reading and printing of data and its types. For example, printf. There is a specific syntax for printf. Printf, the format specifier and the variable name. Printf, comma, variable name. That is the syntax for printf function. Printf function is used to display the formatted output data. Next, scanf. Scanf function is used to read the formatted input data. Syntax, scanf, parenthesis, left parenthesis, format specifier in double quotes, comma, ampersand, variable name. And the data types and format specifier are given. For character data type, format specifier used is %C. For integer, %D. For float, %F. For string, %S. Next, type conversion. The concept of changing one data type to another. The concept of changing one data type to another in C is known as type conversion. C supports two type of type conversions: implicit type conversion and explicit type conversion. C supports type conversion is nothing but C support two type of type conversions: implicit type conversion and explicit type conversion. The concept of changing one data type to another is known as type conversion. Implicit type conversion in C automatically converts any intermediate value to the proper type. C converts in implicit type conversion. C automatically converts intermediate value to the proper type, so that the expression can be evaluated without losing any significance. Implicit type conversion is nothing but C automatically converts an intermediate value to the proper type, so that the expression can be evaluated without losing any significance. This automatic conversion is known as implicit conversion. Here, the lower type is automatically converted to the higher type before the operation proceeds. The result of this is higher type. Next is explicit type conversion. If the conversion of a type to another one is made by a programmer, then it is known as explicit type conversion. Explicit type conversion is nothing but if the conversion of a type to another can be made by a programmer, then it is known as explicit conversion. Syntax for explicit conversion is type, expression. Type given in parenthesis and then expression semicolon. For example, x is the variable here. X is equal to int 7.5. X is the variable here and equal to is the assignment operator. Int is the type and expression is 7.5. Here actually the result is 7. Okay. Another example is given. R is equal to float 10 by 3. Here the result is 3.33. Thank you.